So we're going to consider problems where Fnet matters. Let's do a quick review right here on this front page of what Fnet is. Remember that Fnet is the F in F equals MA. Fnet is the result of all forces on an object. Now, Fnet's referred to in Newton's first law. Newton's first law says if an object, it says that every object continues at rest or in a state of uniform motion unless acted upon by an unbalanced force. Now, if it continues at rest or if it continues to have its velocity, that means its acceleration is 0. Now, Newton's first law says that happens unless there's an unbalanced force. So if there's an unbalanced force, there will be an acceleration, right? And that's what Fnet equals ma is talking about. The Fnet is the unbalanced force that causes a change in velocity. And what I hope to do with you here in 2 more slides is do a little review of units, do a little review of kinematics and dynamics and how you need to be thinking differently when you do kinematics problems versus dynamics problems. And then do one example problem where it shows you just how different the game is now. You cannot pull numbers out of problems and just plug them into equations. You have to stop and think, maybe draw a free body diagram if there's more than one force going on here, analyze all the forces, find this Fnet, and then you can calculate what's going to happen. So let's do that. This slide is simply a review of what we introduced force as last time. It's a review of what dynamics is. You can read it at your leisure if you feel like it. Let's go to the next slide. Now, before we begin, a few really important foundational issues. Weight is Fg. If you want to calculate weight, how could you do it? Ma. The force due to gravity would be equal to the mass times the acceleration that gravity causes. Which Ag would you use? It depends on where you are, right? Your weight depends on where you are, and you better use the acceleration due to gravity where you are if you want to know what your weight is there. Now, what if you wanted to measure Fg? How do you measure your weight? Stand on a scale. If it's you, if it's an object, just put it on a scale. Now, what's Ag? All this stuff is about Fg. What's Ag? That's a rate in change of speed, right? This is how quickly speed changes or velocity changes. Now, what's the average acceleration due to gravity on Earth? Yeah, on average, you'll lose 9.81 meters per second of speed each second if weight is the only force on you. What I want you to recognize is that this, the weight, causes this. Just like if you had a velocity, it causes you to move a distance. And the faster you go, the further you would go. And the more you weigh, the quicker you would accelerate, right? So you would fall quicker in Paris than you would in Denver, because you weigh more in Paris than you do in Denver, even though you have the same mass. But weights are certainly not 9.81. You cannot weigh negative 9.81 meters per second, because negative 9.81 meters per second isn't a force. Your weight is a force. Now, what are the units of force, mass, and acceleration? Let's separate this into metric and English units. What's the metric unit of force? The Newton. A Newton will accelerate an amount of mass measured in kilograms at a rate of some meters per second, depends on how hard you're pushing. That's why a Newton is a kilogram meter per second. It's the amount of force necessary to accelerate 1 kilogram to 1 meter per second of speed in 1 second. Now let's work backwards through the English units. What's the standard English unit of acceleration? Feet per second. How much faster or slower in feet per second you'd be going each second of acceleration. The unit of mass in the English system is the slug. Now, if the Newton is a kilogram meter per second, then the unit of force in English must be what? Well, it is the pound, but what is that really? It's enough force to accelerate a slug of mass to a foot per second of speed in 1 second. You want to make sure as you're doing calculations that you are all metric or all English. If you have a mix of both, choose one or the other, convert one way or the other, and then stick with it. Now this last one, this is really important because it links our old world of motion. We might have described the motion of something as it will move a certain distance in a certain amount of time with a certain v average. It might have a different initial speed or final speed, but we could describe how it would move. That's the world of kinematics. Now we're trying to think about the world of dynamics. And the reason why motion is happening the way it is because of the effect of all of the forces on the object. It's because of the net force. If I ask you, why does an object accelerate? And you say force, you're half right. It's not just force, it's a result of all the forces. And that's why Fnet goes here, not just F. Now what's our link? Fnet causes a change in the motion. Net forces cause acceleration. And we can use acceleration to calculate how far an object will go, how long it'll take to get there, its initial speed, its final speed. So our link between the world of kinematics and dynamics is always going to be acceleration. How quickly is it gaining or losing speed? Now this next slide is a review of what mass and weight are. This is a duplicate from your other notes. I'm not going to insult you by going over it again. But I want to go to this next slide and do this example problem. And when we get done with this example problem, that's where we're going to stop. That will give you enough information to make with reading page 64 and 65, including the examples, to make a good solid attempt at this one problem, force 2, number 1. That's the only problem I want you to do for homework. All right. Now, if there's more than one force acting on an object at one time, each force does not cause the object to accelerate. The sum of the forces does. Now, be careful, because sometimes the other forces that are present aren't mentioned. You have to think about it. Let's consider this. A man exerts an upward force of 175 newtons as he lifts an object that has a mass of 14 kilograms. What's the acceleration? Do you see how tempting it would be? What's this? force. What's this? M. Do you see how tempting it would be to do A is F over M and stop? If you do that, you are dead wrong. You're off in left field. You have no clue what we're doing. Picking out numbers as a way to save problems will epically fail. What you have to do is think about the situation. Why do you have to use a force at all to lift something? Because you have to overcome what it weighs. Do we know what this object weighs? No. Can we figure out what it weighs? Yes. This object has a mass of 14 kilograms. To calculate its weight, we would do mass times AG. So 14 kilograms, do we know where it was weighed? Nope, so we approximate, times negative 9.81 meters per second per second. When you calculate that, you get negative 137.34 newtons. The 137.34 newtons, that is this object's what? Weight. Is that the only force on it? No, he is also pulling on it, right? Free body diagram. Here's the object. He's pulling up with a force of 175 newtons. Gravity is pulling down with a force of 137.34 newtons. Finding F net is different every time. In this case, the forces are in a straight line. When forces are in a straight line, we can use algebra to combine them. The force that the man is exerting and the force of gravity are both exerted on the object, and they're both on the object at the same time. So we can simply add them together. The man exerts a force of 175 newtons. I made it positive because he's pulling up. Gravity is pulling down with a force of 137.34 newtons. I made it negative because gravity pulls down. Do you see that together, that adds up to this, 37.66 newtons? And that's the force I would use in A equals F over M. So when you're going to do a net force problem, you have to take a look at all the forces on the object. If you're doing something up and down, isn't gravity going to be one of the important forces? So even if the problem doesn't tell you, hey, go find what this object weighs, its weight is an important reason why it moves the way it does.